Dear students, today we'll discuss about the first chapter of class 12, that is electric charges and field. Right now we have studied about charge in class 10, and the symbol of charge is, we know what it is, Q. Right, we denote charge by Q. Right now, charges, they are having so many characteristics are there, we have studied, right? And the one of these most important characteristics are that we know same charges will repulse each other, and the different charges, that is positive negative, will attract each other, right? And for that reason, right, we know here another characteristic of charge is there that we'll discuss briefly in the topic, that is quantization of charge. Now, what is that quantization of charge? Quantization of charge is, if suppose you want to find out the charges present in any object, right? So that charges present in any object will be always equals to the number of the smallest particles present in that object. Now, what is that smallest particle of the object? The smallest particle of charge is actually, which we denoted by E, and the value of E is 1.6 into 10 to the power minus 19 Coulomb, right? And the Coulomb is the charge of Coulomb is the unit of charge, right? So the charges present in that box will be the how many number of the smallest charge is present in that object. That is, if suppose the number is n, so the charge of that box will be the multiplication of n and into E. That is, so Q will be equals to, that is number of charge present in that box, Q will be equals to n into E, right? That is how you can find out the charge present in that box, that will be equals to Q equals to n into E. If you know the number, right, and if you multiply by that value, small value E, you can find out the value. And the main thing is that, in class 10 we have studied another thing, that is current, which is equals to the charges flowing through a conductor in 1 second. That is your charge, that is your current, right? Which are flowing in 1 second in a conductor, that is actually current. We have studied in class 10. So we know that is current is equals to Q by T. So the numerical may give you like that, the number of charge, right, or the current they will give, you have to find out the time, or they will give the charge, you have to find out current and time as well, right? We'll discuss numericals part, we are not discussing in that video. Numericals part we'll discuss in my next video, right? Now let's focus on the theoretical part only. So this is the smallest theoretical part which are related to static charges, right? Now in this video, first I said that we know every charges, right, attract, every different charges like positive and negative attracts, and similar charges repulse each other. Like suppose if I take two similar charges, like suppose positive and positive, so there should be a repulsive force in between them. So what will be the repulsive force in between? These two forces should be in different direction, right? Because these two are similar charge, the repulsive, so the forces between that will be the repulsive force. If I take two different charges, suppose positive and negative, so the charges between, force between them will be the attractive force. The direction of the force will be this way, right? Now we know here we can see that these two charges, right, are attracting or repulsing by some forces, right? That force we can find out by a law that is called Coulomb's law. Coulomb's law totally deals with how the attraction or repulsion force is acting, right, in two charges, right? Let's see how this we are finding out. Let's find out that what will be the expression of that repulsive or attraction force between two charges. Let's see. Suppose here I am taking two charges, Q1 and Q2, right? Now I don't know whether these two charges are positive or negative. That means we can't say the direction right now, right? So I am just assuming there are two charges, that is Q1 and Q2. So there should be a repulsive or attraction force, because we don't know whether it is positive or negative, right? So the attraction repulsive force between these two charges will be proportional to the multiplication of these two charges, right? That means greater will be charges, more will be charges, more will be the attraction or repulsion force between two charges, right? And you can see from the figure that these two charges should be in some distance, right? And that distance is suppose smaller, right? Now from that figure, you know, if I place these two charges more distance, if I set these two charges in some more distance, the attraction or repulsion force will be definitely less. So according to Coulomb's law, that attraction or repulsion force should be inversely proportional to the square of the distance, Now here, as I did not mention the positive or negative sign here, so that's why you have to put a modulus sign here, because if suppose that is positive or that is negative charge, so you have to take the direction. So that means if I give the modulus sign, it will be in general, right, whether you are taking positive or negative charge, right? Now if I combine these two forces, two equations, it will come F will be proportional to Q1 Q2 modulus R square, right? Now as here it is a proportional sign is there, so if you want to write the equal, you know, always to convert proportional to equal sign, you have to put one constant, right? Suppose here that constant is K, so the expression will become Q1 Q2 by R square. This is the expression. Now this K should have a new value, right? Now can you tell me some other equations which is just similar to this equation? Remember, we have studied in class 9 probably, right? Yes, you are right. That equation is the equation from gravitation, right? So what is the equation? We have studied that if you place two objects which are having two different masses m1 and m2 with some distance d, so the gravitational force is equals to g m1 m2 by d square. So the equation is almost similar like that, and that we know that g should have some values, right? We know. Now let's forget about this gravitation part. I have just given this equation just to memorize, right? Now that k have some another expression. The expression of k is 1 by 4 pi epsilon naught into Q1 Q2 by R square. Now this is the main constant which will be represented in Coulomb's law. It is the final equation of Coulomb's law. Here the epsilon naught is denoted is permittivity. That I will explain that epsilon naught part, right? That part, that is permittivity, in my next video particularly, because this is very important, right? Now here this epsilon naught has some values, right? And the value of the epsilon naught is equals to 8.854 into 10 to the power minus 12, right? Now here the value of, the unit of this epsilon naught, suppose I forgot, right? Here I am not writing the unit of epsilon naught. Now how you can find out the unit of epsilon naught from this equation? You can easily find out from this equation. How? Here you know epsilon naught. From this equation you can write out epsilon naught. That epsilon naught is equals to Q1 Q2 by F into R square. Here I am not writing the 4 pi part because 4 pi is a constant, right? So this is the expression you will get from this equation. Now you know the unit of charges, that is Coulomb, so C into C, and the unit of F is also you know, that is Newton, and distance you know, meter square. So the unit of epsilon naught will become C square, that is Coulomb square, Newton to the power minus 1, m to the power minus 2. That is the unit of epsilon naught. If you forgot also, if you are forgetting also while you are writing, so you can find out from this equation directly, right? So now I can write the unit of it is coming C square, that is Coulomb square, Newton to the power minus 1, meter to the power minus 2, right? Okay. Now if I put this value 8.854 here, the whole constant, suppose the value of k 1 by 4 pi epsilon naught. Now if I put this value of 4 into pi, the value of pi we know 22 by 7, and the value of epsilon naught is here 8.85 into 10 to the power minus 12. This whole expression is coming actually 9 into 10 to the power 9, right? 9 into 10 to the power 9. So the whole expression, the value of the whole expression is actually 9 into 10 to the power 9. These two values you have to mark up. One, the value of 1 by 4 pi epsilon, that is the value of k, is equals to 9 into 10 to the power 9, and the value of epsilon naught, that is 8.854 into 10 to the power minus 12 Coulomb square into the power minus 1 and to the power minus 2. So these two things you have to mark up, right? Now let's come to the main important thing, that is, if suppose I tell you find out the definition, or tell me the definition of 1 Coulomb charge from this equation, can you tell me? Now you can easily tell me, that is, now we got the final equation from Coulomb's law, right? What is that final equation? That final equation, F is equals to 1 by 4 pi epsilon naught into Q1 Q2 by R square, right? Now suppose here I have, in this equation I am taking suppose the two charges, I am taking suppose two charges, these two charges which is equal, right? Like suppose Q1, sorry, two charges are equal, that is Q1 equals to Q2, and the value of these two charges is suppose 1 Coulomb, right? And I have placed these two charges in a distance of 1 meter suppose. Now if I put these values in this equation, what it will be? 1 by 4 pi epsilon naught into 1 into 1 divided by, that is F is coming 1 by 4 pi epsilon naught. Now do you know the value of this? Yes, just in previous equation we got this value, and that value is 9 into 10 to the power 9, and here it will be Newton. Now let's sum up these whole things. Now here the force is coming 9 into 10 to the power 9 Newton. When? In which case? When the charges are equal, that is 1 Coulomb, and the distance between them is 1 meter. Now in repeatedly, if I say this equation in that way, that if we take two equal charges and place them in 1 meter distance, after placing in 1 meter distance, if I get a force of 9 into 10 to the power 9 Newton, that means that two charges what I have taken, equal charges, that two charges should be 1 Coulomb charge. That is the definition, right? See how simple it is, you can find out from this equation. So that is, we have finished the topic, that is Coulomb's law. In my next video, we'll discuss the vectorial thing, the vector related in Coulomb's law, how the vector you will apply in Coulomb's law, and as well as the smallest thing, that is this part, permittivity. Okay? Thank you.